Welcome back to eCoreAcademy learners. My name is Anita and I am one of the teachers and co-founders here along with my younger brother AJ. Today I have a new Algebra 2 lesson prepared for all of you, and it's going to be a continuation of the last video I made. If you don't remember the topic, well, it's up on the screen and it's standard form of a quadratic function. As this says, this is part 2, so the last video was part 1. Let me just do a quick recap of part 1. In part 1, I introduced you to standard form, or I reintroduced you to standard form if you remember it from quadratics in Algebra 1. Then we went through the 6-step graphing process of how to graph a parabola when you have a quadratic function in standard form, because it's a little bit different than graphing a parabola using a quadratic function in vertex form. And lastly, we did a practice problem together. In this video, we're going to be doing mainly practice problems. I have 4 practice problems planned and written, and we're going to be working through them. I'm going to give you the practice problem, then I'll give you the written out solution in case you want to just pause and copy that down so you can listen to me on the next slide. And then on the next slide, I will be running through the solution. I'll be handwriting it on the screen so you can just follow along. And I'm going to try to make it as much of a hands-on approach as possible. Before we even get started, I would really appreciate it if you pause the video and hit the like button to support me and AJ as teachers here on eCoreAcademy. Also, subscribe to the channel so you can join our brilliant expanding student community. Don't feel afraid to drop a comment down below. We'd love to hear your thoughts. And also hit the post notification button so you're notified of our latest posts. Use our socials in the description box below to share about eCoreAcademy on all our social media platforms, including Facebook, Twitter, and Instagram, so you can spread the word and get as many of your family members and friends involved as possible. Okay, let's get right into the video. Let's look at 4 challenging practice problems on standard form of a quadratic function. Okay, so let's look at the first practice problem. I'm just calling these practice problems, the titles are just the type of practice problem they are. Like in this case, it says converting to vertex form. So in this practice problem, as you can probably tell, we're going to be given standard form. And we're going to be asked to convert it to vertex form. So let's look at the problem. What is the vertex form of the quadratic function, which is written in standard form, y equals 4x squared plus 8x plus 7? Right underneath this, I've given you a reminder that vertex form is y equals a times the quantity x minus h squared plus k. So this is vertex form. Let me just underline this. This is vertex form. And this is vertex form down here, and this up this is vertex form, and then right underneath this, I'm going to write it in standard form. Y equals ax squared plus bx plus c. So this is standard form, and this is standard form is what this equation right here is written in. So a is 4, b is 8, and c is 7. So we're going to be converting this into standard form. Let's see how to do it. So I've written the problem at the top of the screen just in case you want to refer back to it. Here is the solution where I've already written it out for you. So if you would like to pause the video and copy this down, feel free to do so. If you just want to listen to me explain it on the next slide, this is also a little bit more organized and neat in case you struggle to read my handwriting. So please feel free to pause it and look over the answer if you want. I'll give you a second. Okay, for those of you who want me to walk through this problem, let's go right to the next slide. So again, the problem appears at the top of the screen. We're going to be solving the problem together. So I have the solution right next to me. I'm going to walk you through it and also explain it at the same time. So what is the vertex form of y equals 4x squared plus 8x plus 7? So let me just write vertex form right here in case we've forgotten for some reason, but at this point you shouldn't have forgotten. Y equals a times x minus h squared plus k. So in this equation, remember how I said that a is 4, b is 8, and c is 7? Well, those are the values we've been given. So now we got to identify what are we trying to find. In this case, we have a, h, and k. So we're trying to find, I'm just going to write it here, we're trying to find a, h, and k. So those are the values we're trying to find. Remember, hk is the value of the vertex. That's the coordinate. HK is the vertex. And when we have standard form, we can't directly find the vertex just by looking at standard form. We got to manipulate it. Remember negative b over 2a from the last video. We've got to do those kinds of things to find out what HK is. So let's get right into it. First, let's try to find out what a is. If you remember from the last video, if you look at the equation I've given you, y equals 4x squared plus 8x plus 7, a is the same in vertex form as it is in standard form. A determines which way your parabola opens. Does it open upward, or is it reflected across the x-axis, and does it open downward? And it also determines if your parabola is vertically compressed, meaning it's a decimal. A is a decimal value, like our fraction value, 1/2, negative 0.75, or if it is vertically stretched, meaning your a value is a value larger than 1. So something like larger than 1 or less than negative 1, like negative 5, 27, 100, negative 500. So that's what a is, and it's common amongst vertex form and standard form. Therefore, we already know what the value of a is. If we refer back to the equation we've been given in standard form, it's 4. A in this case is 4, so a in vertex form is also 4. So we've already figured out the first part. Now let's try to find out, I'm just going to put a dividing line just to organize this. Let's find out what h is now. Remember, h is the y-coordinate of the vertex, and it's also your axis of symmetry. So how do we find h, which is our x-coordinate of the vertex, with standard form? Do you remember negative b over 2a? Well, that's what we're going to be using. So let's do that right down here. I'm just going to write h, but remember, x-coordinate of the vertex. So we look up here and we apply that negative b over 2a that we learned. So I'm just going to write it here as well, but by now you should know it. Negative b over 2a. So if we look at our standard form written at the top of the screen, y equals 4x squared plus 8x plus 7, we're going to do negative b over 2a. So negative b is negative 8. So I'm just going to write here negative times the value 8 over 2 times a. So what is a in this case? Well, a is 4. So 2 times 4. And then we're just going to simplify this. So this becomes negative. Negative times 8 is negative 8. 2 times 4 is 8. And then negative 8 divided by 8 is negative 1. Now we have to figure out what k is. Remember, k is the y-coordinate of the vertex. So we find k by taking our x value and plugging it back into the quadratic function. In this case, we're going to take negative 1, which we found to be our x value, and plug it back into y equals 4x squared plus 8x plus 7, and we'll find the y value of the vertex, which is k. So let's do that over here. I'm going to write it at the bottom of the screen. K equals, we're using this quadratic equation in standard form. So 4 times the value, remember we're plugging negative 1 in for x, negative 1 squared plus 8 times negative 1 plus 7. Then we simplify it further. 4 times negative 1 squared is just 1. 8 times negative 1 is negative 8 plus 7. I'm just going to write it right here. 4 times 1 is 4. And then you just get negative 8 plus 7. Carry that over. And 4 minus 8 is equal to negative 4. Negative 4 plus 7 is equal to 3. So our k value is 3. So from this, we now know, I'm just going to divide this here. From this, we now know that the coordinates of our vertex, I'm just going to write it up here, vertex is equal to negative 1, 3. So now we have to put it together, and we have to convert all of this into vertex form. So remember, refer to vertex form that I've written up here. Our a value is 4, so y equals 4 times the quantity x. Our x value, which is h, is negative 1. Negative 1 times negative, because remember, we already have that negative, is plus 1. We do the opposite, squared, and then our k value is 3. So plus 3. And this is our final answer. We just box it in so that it stands out on the screen. We converted from standard form to vertex form, and this is exactly how we did it. We identified what we need to find as in a, h, and k, and we found each of those variables and we put them together, and then we rewrote it in vertex form. So that's how we solved that problem. Let's move on to the next problem. We're going to be finding unknown coefficients. This is going to be a little bit more complicated. So here's the problem. For this function, the vertex is given, so we know the vertex, but you need to find the unknown coefficients. And the function is written right below it. Here, right here is the function. Y equals ax squared plus 6x plus c. So as you can see, our unknown coefficients are a and c, and the vertex is given. This is the vertex. 0.5, 2.5, this is our h, and this is our k. Okay, so let's go into the solution. So I've written the problem at the top of the screen just so you can refer back to it. Our solution is right here. I've already pre-written it for you. We're trying to find A and C again, and this is the whole process to do that. And if you want to pause the video and copy it down, feel free to do so. I'll give you a second. Okay, let's continue into the next slide where I will be explaining this solution to you. We're going to be solving it together. So I want to write down what we're trying to find. As I said before, we're trying to find A and C because those are our unknown coefficients. So let me just write that up here. We're trying to find A and C. Okay, so let's start with trying to find A first. A is our first value. It determines which way our parabola opens up, upward or downward, if it's vertically compressed or stretched, etc. So how do we find A? This is how I found A. Remember how we referred to that little equation, that formula to find the x value of the vertex? X equals negative b over 2a. Well, we can use that here. Let me show you how. We know what x is equal to. In this case, we're not trying to find x. We're going to be using that equation, and we're going to be trying to find the a in that equation. Let me show you exactly how. Okay, so let's find the a value. I'll be showing you how exactly to do that. So think of that formula we kind of know. X equals negative b over 2a. So in this case, we know the x value. We know h of the vertex, which is 0.5. So I'm going to substitute 0.5 in for x. So I'm going to write 0.5 equals, we also know what b is. B is equal to 6. So the negative value of 6 over 2a, but we don't know what a is. In this case, a is our only variable, so we're going to be able to find a using this. We're kind of substituting different variables in. Instead of trying to find what x is using a and b, we're going to be trying to find what a is using x and b. So let's just solve that. Next, what we do is we just find the negative value of 6, so 0.5 equals negative 6 over 2a. Afterwards, we want to get 2a out of the denominator, so I would multiply both sides by 2a, and then we get 2a times 0.5, whatever that value is. We're not going to multiply them together yet, and then if we multiply this side by 2a over 1, the 2a's cancel out, and we just get negative 6 by itself. Then after that, what we're going to do is we're going to divide both sides by 0.5 because we're going to get 2a by itself. So 2a equals negative 6 over 0.5. I'm going to continue up here. And then afterwards, we get 2a equals, well, what is negative 6 divided by 0.5? It's negative 6 divided by 1/2, which is just negative 6 times 2, which is negative 12. So that's just some mental math you should have been able to do. And then you just divide both sides by 2, and you get a is equal to negative 6. So we found the value of a. Let's find the value of c now. So remember, c is just your y-intercept, and we're going to find it by plugging these values that we already know what a is. We're going to be putting that into this equation right here, and we're going to be plugging the vertex also into this equation. So x and y are filled out, so our only number left is c. So let me show you what exactly we're going to be doing. So instead of y, we're going to put 2.5 in because 2.5 is the y value of the vertex. So 2.5 equals negative 6 because negative 6 is our a value times 0.5 squared plus 6 times 0.5 plus c. We don't know what c is. C is our y-intercept, but we don't know the exact value. So let's just simplify this further. So 2.5 equals, well, so 0.5 squared is just 0.25 plus 6 times 0.5 is 3 plus c, and then continue simplifying. 2.5 equals negative 6 times 0.25 is equal to negative 1.5 plus 3 plus c, and we continue to simplify. 2.5 equals negative 1.5 plus 3 is equal to positive 1.5 plus c, and if we subtract 1.5 from both sides to get c by itself, we find that c is equal to 1. So we also found c. Now let's plug a and c into this equation right here so we can get the complete equation. So our final answer is, let me just erase that. I don't know why I wrote a. Okay, let's write the final equation here, which is y equals negative 6 x squared plus 6x plus 1. This is your final answer. And make sure you also mention what the values of c are and how you found them as well. That's why I'm circling these as well. So you just found the missing coefficients. If you're able to stick through that, I'm proud of you. Okay, let's go to the next problem. We're going to be finding the y-intercept now. Here's the problem. For the function, find the y-intercept. Y equals the quantity x minus 9 squared plus 5. So in this case, it's not written in standard form. Let me write standard form right below it. Y equals ax squared plus bx plus c. In this case, if we had the c value, we could immediately just say this was the y-intercept, because remember, c value is the y-intercept. However, we've been given this quadratic in a bit different form. So from this, let me just erase that. We've been given this quadratic equation in a bit different form. So there's an easy way to solve this. Let me show you how. And here's a reminder that might help you immediately click in your head exactly how to solve this problem. Remember that you find the y-intercept when x equals 0. So what do you think we should do? Just think about that for a second. Remember that you find the y-intercept, which is the y value, when x is equal to 0. Because remember, the y-intercept is when your graph touches the y-axis. When it touches the y-axis, your x-coordinate is automatically 0. You can assume that. You know that. Here, you've been given the quadratic function, and you know that x has to equal 0. So one of your two variables is already known. So now you only have to solve for y. And let's see exactly how you do this if you didn't get it by now. The problem's at the top of the screen just for you to refer back to, and here's the pre-written solution. So if x is equal to 0, you just plug 0 in for x, and you just solve this quadratic normally, and you'll figure out what y is. And then you'll be able to write the y-intercept as a point. Let's walk through this together. I'm also going to show you how to do this problem. Okay, on the next slide, we're going to be solving this together. Again, problem at the top of the screen for you to refer back to. Okay, so we're going to be solving the problem together. Let me just remind you, you find the y-intercept when x is equal to 0. That's very fundamental, and remember that. Now we're going to be plugging 0 back into this equation up here. Y equals the quantity x minus 9 squared plus 5. So let's do that. Y equals, remember we're plugging 0 in for x, so 0 minus 9, that quantity squared, plus 5. Let's work with what is inside the parentheses first. So 0 minus 9 is negative 9, and then we're squaring that, plus 5, and then we're going to be squaring the quantity negative 9. Negative 9 times negative 9 is 81. Then you want to add that to 5. And then you see that y is equal to 86. So these are your two coordinates, your x-coordinate and your y-coordinate. So now let's write the final answer, but we're going to write the answer as a point. So your y-intercept is equal to the point 0.86. For the quadratic equation, y equals the quantity x minus 9 squared plus 5. So this would be your final answer, and this is the workout of how we got to that final answer written on the screen right here. So hopefully that was probably the easiest problem out of all of these. So I expect you to have gotten that, but if you didn't, no problem at all. Just replay that, and hopefully you'll get it the next time. Okay, now it's going to be doing probably the hardest problem here. So And I say this because it's kind of difficult to understand, but at the same time, there's a lot of work involved. So gotta be patient if you don't understand this one. So we're gonna be finding a and b. So in a standard form, you got y equals ax squared plus bx plus c. So we're gonna have the c value, but we're not gonna have either the a value or the b value. We're also gonna have the vertex. So using the y-intercept and the vertex, we have to find out what the a and b value are. I'll show you exactly how we do that, but first let me show you the exact problem. For this function, the vertex is given, but you need to find a and b. The function itself is y equals ax squared plus bx plus 5. So you don't know a and b, but you know 5, which is your y-intercept. You also know the vertex, which is -2, -3. So let's get into exactly how you would solve this problem. First, I'm gonna always have the problem at the top of the slide in case you want to refer back to it. Here is the pre-written solution. It's quite a bit of work. You have a graph on there, which is a sketch, and then you have a lot of work to the right side. As you can see, we're going to be using elimination method, which we also used in a previous video, 2 videos ago, when we were doing practice problems with vertex form. Here we're also going to be using elimination method because we have 2 variables. So let's go to the next slide, and I've broken the solution down in 2 parts. One slide, we're just going to be doing this graph that I have up here together. Next slide, we will be doing this actual workout, all the stuff on the right. I wanted it to look less cluttered and so that you could follow along easier. So graph on one slide, workout on the next slide. Let's get right into it. So part 1 of the solution, the graph. Again, problem at the top of the screen to refer back to. Here is us solving the problem together, and here is the graph that we have to work with. Okay, so what do we already know? We already know that the equation we have is y equals ax squared. Also, the reason I've changed to red is because I'm going to be writing on this graph. It's easier for you to see. So this is what we know so far. We also know that the vertex is equal to negative 2, -3. We also know another point. So the more points you know on a graph, the more valuable information you have. So the easier it is for you to figure out what the whole graph is. We also know the y-intercept because we have the c value, so it's 0, 5. Let's plot these 2 points on the graph, and I'll show you what I'm talking about. So -2 is over here, and then -3 is down here. So I'll just put a dot on that point. Then we also put 0, 5, 0, come up 5. So we only know 2 points. So we only know half of the parabola. If we find what the other half of the parabola is, we essentially find another point, and we can definitely solve this problem. So let me show you what we do. So you see how this point is 2 units horizontally away from this value. So 1, 2, it's only 2 points away. So it's 2 points to the right of the vertex. 0, 5 is 2 points to the right of the vertex. So what if we go 2 points to the left of the vertex, but we stay on the same horizontal line? So if we go 2 points to the left of the vertex, 1, 2, we come over here and we're staying on the same horizontal line. So we just reflected our y-intercept across the axis of symmetry, which is this line right here. And we stayed along that same horizontal line, which is here, which is this horizontal line is y equals 5. And we just found another point. Oh, I'm sorry. This drawing is pretty bad. So hopefully you understand, we just reflected that point across the axis of symmetry, and we just found another point. So that's very valuable. And what is this point right here? Well, this point is exactly a -4, 5. So let me just write this here. This point is very important, -4, 5. And on the next slide, I'll show you exactly how we use -4, 5 and our vertex -2, -3 to solve this and find what a and b are. Okay, part 2 of the solution, we're going to be doing the workout using the 2 points we found. So, the 1 point we found, using the vertex, -2, -3, and this reflected point that is the reflection of the y-intercept across our axis of symmetry. And this point that we found was -4, 5. So let me show you exactly how we're going to be doing that. Again, problem at the top of the screen, solving the problem together, continued. Okay, so what we're going to be doing is we're going to be taking this quadratic we have so far, y equals ax squared plus bx plus 5, and we are going to be plugging the vertex into this, and also that point 4, -4, 5 into that. So at the top, we'll be doing the vertex, and then right underneath that on this slide, I'll be doing the other point, -4, 5. Then we are going to have A and B, and we're going to cancel B out. We're going to find what the A value is, and then we'll refer back and we'll solve the B value. I'll show you exactly how we're going to do that. So we know our vertex is -2, -3. We're going to plug -2 in for x and -3 in for y. So let's do that right over here. -3 equals a times the value -2 squared plus b times -2 plus 5. So we just plugged -3 in for y and -2 in for x. So then we're just going to simplify. -3 equals a times -2 squared is 4. So times 4 plus, I'm just going to bring this down, plus b times -2 plus 5. Then we get -3 equals a times 4. We can just rewrite that as 4a. And -2 times b, we can just rewrite that as -2b plus 5. Let's subtract 5 from both sides to get these variables by themselves. And if we do that, -3 minus 5 is -8. So -8 equals 4a minus 2b. And just for our ease, let's divide all of these terms by 2 so that we can simplify as much as possible, because 2 goes into all these coefficients. So -8 divided by 2 is -4. 4 divided by 2 is 2, and then we have the a, and -2 divided by 2 is -1, so just minus b. So this is our first equation. I'm just going to draw a dashed line here, and we're going to plug the point -4, 5 in also instead. So we're going to take y equals ax squared plus bx plus 5. We're going to do the exact same thing we just did with the vertex with the point -4, 5. So we're going to plug in -4 in for x and 5 in for y. So let's do it right below. So 5 equals a times the value of -4 squared plus b times -4 plus 5. So then we just continue. 5 equals a times -4 squared is 16, so times 16. And we just bring this b times -4 down, plus 5. Continue on. 5 equals, we can just write a times 16 as 16a. And then b times -4, we write that as -4b plus 5. We want to get these two variables by themselves, so let's subtract 5 from both sides. We get 0 equals 16a minus 4b, and if you see this again, our coefficients 16 and 4. 4 goes into both of these values, so we can divide them all by 4, so we can simplify this even further so it's easier on ourselves. So if we divide all these by 4, 0 divided by 4 is 0, 16 divided by 4 is 4, and then we just have the a, and -4 divided by 4 is -b. So these are the two equations we've come up with. We still have the a and the b, but now we got to use elimination method to get rid of one of them. And I've picked b. I'm going to get rid of b, so let me show you exactly how you would get rid of b up here. So come up here. We're just going to rewrite these two equations. -4 equals 2a minus b. And we're also going to write 0 equals 4a plus, I got ahead of myself there. 0 equals 4a minus b. Okay, so now we're going to add these. However, we have a problem. 2a and 4a don't cancel out, and neither do -b and -b. Therefore, you got to pick one of these, and because I'm trying to get rid of b, I'm going to pick one of these equations and multiply it times -1, so one of the b's becomes positive, and the b's cancel out. So I just picked the second equation, and I'm going to multiply this whole thing by -1. So times -1. I'm just going to write it right underneath it. So 0 times -1, still 0. 4a times -1 is -4a, and -b times -1 is positive b. So now we get this new equation. I'm just going to cross this out so you guys don't get confused. -4 plus 0 is just -4. 2a minus 4a is equal to -2a, and then your b's just cancel out. At this point, we can get a by itself by dividing both sides by -2. -4 divided by -2 is 2. So we get a equals 2. We solved the first part. Now we got to figure out what b is equal to. So you can either pick this equation right here, -4 equals 2a minus b, or you can pick 0 equals 4a minus b, and you can just plug 2 back in for a and find out what b is. I picked this one down here because it's just easier to work with, in my opinion. So let's do that over here. So a 0 equals 4 times 2. We're plugging 2 in for a. 2 minus b. 0 equals 4 times 2 is 8. So 8 minus b. Let's subtract 8 from both sides to get b by itself. So we get negative b is equal to 0 minus 8, which is negative 8. And then multiply both sides by -1 to get rid of this negative sign in front of the b. We get b equals -1 times -8 is 8. So we get b equals -8. So we have these two answers. If we put it all together and we write the final, the whole quadratic equation in standard function in standard form, we write it as y equals the value of a is 2x squared, plus the value of b is 8x plus 5. So this right here is our answer. Again, also circle your a and your b values because that's also part of the answer. And that is how you solve that using elimination method. That is a lot of work, but if you're able to stick through that, I'm very proud of you. If not, feel free to go back through the video and rewatch that. There's no problem in doing so. So that's all I have for you students today. I hope you enjoyed the video. Again, I really enjoy doing practice problems with all of you because I think it's really fun to just run through them and give you my advice and see if you all can come up with different ways, maybe even easier ways to solve these problems. So if you were able to come up with a different way, feel free to drop a comment down below of what you thought. Also, what else do I have to tell you? Okay, so please like the video if you enjoyed my teaching style. Also, subscribe to our channel and join our student community. Hit the post notification bell so you're notified of our latest posts. If you don't frequently check YouTube, those notifications will just immediately alert you when our videos come out. And lastly, follow our socials, Facebook, Instagram, and Twitter. We inform you of all of our posts, all of the videos that are going out. So in case you forget, in case you don't see the notification, you will definitely get notified if you follow our social media accounts. Our website is going up soon. I know I keep reiterating this, but I promise it is going up soon. And it is going to have so many sweet functionalities for all of you students, things that you can't access on the YouTube channel. These include notes and a quiz and all these other sweet tips. Also, courses are organized, so if you're trying to go through all these courses in an organized method, you should definitely visit the website. All you have to do is sign up, and it's all free content at the tips of your fingers, exclusive notes made by AJ and myself. Lastly, if you have any personal or business inquiries, please reach out to us at eCoreAcademy@gmail.com. That's all I have for you today. Please enjoy the rest of the day. Hopefully you liked running through those practice problems with me, and look for my next Algebra 2 video. Bye.